Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I want to remind our awesome listeners that if you're enjoying the show, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
Absolutely, Sheila. And hello, everyone. We're excited to continue our journey through Season 2, where we're exploring core hole punch technologies. Today, we're diving deeper into Chapter 2, Hyperswarm Networking, and specifically, we'll be discussing connection management.
That's right, Victor. And to kick things off, I've got a tricky quiz question for our listeners. Are you ready?
I'm always ready for a challenge, Sheila. Bring it on.
All right, here goes. In a Hyperswarm network, what's the primary challenge when managing connections between peers behind different types of NATs, network address translations?
Ooh, that's a great question, Sheila. It really gets to the heart of one of the trickiest aspects of peer-to-peer networking. NATs can be quite the obstacle in establishing direct connections between peers. I'm curious to see how our listeners approach this. What do you think, Sheila? Any initial thoughts without giving away the answer?
Well, Victor, I think it's a fascinating problem. NATs are like the bouncers of the internet world, controlling who gets in and out of private networks. I can imagine it might involve some clever negotiation techniques, but I am excited to learn more about how Hyperswarm handles this. Now, before we dive deeper, could you give our listeners a quick refresher on what NAT is?
Of course. NAT, or Network Address Translation, is a method used by routers to translate private IP addresses within a local network to a public IP address. This allows multiple devices on a private network to share a single public IP address. While it's great for conserving IP addresses and providing some security, it can complicate direct peer-to-peer connections.
Thanks for that explanation, Victor. It really sets the stage for our discussion. Now, let's start our journey into connection management in Hyperswarm. Can you give us an overview of what this entails?
Certainly. Connection management in Hyperswarm is all about establishing, maintaining, and gracefully ending connections between peers in a decentralized network. It's like orchestrating a massive global party where guests, or peers, are constantly arriving, mingling, and leaving.
That's an interesting analogy. So, how does Hyperswarm actually establish these connections?
Great question. Hyperswarm uses a process called Holepunching to establish direct connections between peers, even if they're behind NATs. Holepunching is a technique that creates a pathway through the NAT, allowing direct communication. It's like two people trying to meet in a crowded place. They need a way to find each other and create a direct line of communication.
Hole punching sounds intriguing. Could you break that down a bit more?
Of course, hole punching involves creating a pathway through the NAT by having both peers send packets to each other simultaneously. This punches a hole in the NAT, allowing direct communication. It's similar to two people waving at each other in a crowd until they spot one another and can meet up.
I see. So once the connection is established, how does Hyperswarm maintain it?
Excellent question. Hyperswarm uses a combination of techniques to keep connections alive. This includes periodic keep alive messages, which are like little nudges to say, "Hey, I'm still here." It also employs connection health checks to ensure the quality of the connection remains good.
That makes sense. But what happens when a connection is lost? How does Hyperswarm handle disconnections?
Disconnections, the party guests who leave without saying goodbye. Hyperswarm is designed to handle these gracefully. When a disconnection is detected, it first attempts to re-establish the connection. If that fails, it updates its internal state and notifies the application. It's like having a good host who notices when someone has left and updates the guest list.
Interesting. Are there any specific strategies for reconnection?
Absolutely. Hyperswarm implements exponential backoff for reconnection attempts. This means it tries to reconnect immediately at first, but if it fails, it waits longer between each subsequent attempt. It's like trying to call a friend who's not picking up. You might try again quickly at first, but then give it more time between attempts.
That's a smart approach. Now I'm curious. How does this compare to traditional client-server connection management?
Great question. In client-server models, connection management is more straightforward because servers have stable, public addresses. P2P systems like Hyperswarm face additional challenges due to NATs, dynamic IP addresses, and the lack of a central authority. It's like comparing a structured dance, client-server, to a free-form dance party, P2P.
That's a helpful comparison, Victor. Now, let's address a common misunderstanding. Some people might think that once a connection is established in a P2P network, it's permanent. Can you clarify why that's not the case?
Absolutely, Sheila. That's a great point to address. In P2P networks like Hyperswarm, connections are dynamic and can be interrupted for various reasons: network issues, peers going offline, or even changes in NAT configurations. That's why robust connection management, including handling disconnections and reconnections, is crucial. It's more like maintaining friendships. It requires ongoing effort and adaptability.
Thanks for clarifying that, Victor. Now, do you have any best practices or tips for developers working with Hyperswarm's connection management?
Certainly, one key tip is to always design your application to be resilient to disconnections. Don't assume connections will remain stable indefinitely. Also, implement proper error handling and logging for connection events. It'll save you a lot of headaches during debugging. Lastly, consider implementing your own application-level keep-alive mechanism on top of Hyperswarms for critical connections.
Those are great tips, Victor. Before we wrap up, do you have any interesting facts or anecdotes about connection management in P2P systems?
Actually, I do. Did you know that the concept of hole-punching was inspired by techniques used in online gaming to allow players to connect directly to each other? It's a great example of how innovations in one field can lead to breakthroughs in another.
That's fascinating, Victor. Now let's circle back to our quiz question. Can you reveal the answer?
Of course, the primary challenge in managing connections between peers behind different types of NATs is the NAT traversal problem. Different NAT types have varying levels of restrictiveness, and some combinations can make it impossible to establish a direct connection without the help of a relay server. Hyperswarm uses sophisticated NAT traversal techniques, including the hole-punching we discussed, to overcome these challenges in many cases.
Thank you, Victor. That wraps up our episode on connection management in Hyperswarm. To summarize the key points. Point 1. Hyperswarm uses hole-punching to establish connections through NATs. Point 2. Connections are maintained with keep-alive messages and health checks. Point 3. Disconnections are handled gracefully with reconnection attempts using exponential back-off. 4. P2P connection management is more complex than traditional client-server models. 5. Developers should design for resilience and implement proper error handling.
Excellent summary, Sheila. And remember, listeners, connection management is like maintaining friendships in a bustling, ever-changing party. It requires attention, adaptability, and resilience.
Absolutely, Victor. And to our wonderful listeners, we hope you found this episode informative and engaging. If you did, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us keep creating this content. Don't forget to subscribe and rate our podcast. It really helps us reach more developers like you. Until next time, happy coding.